going to do 2, 7 absolute value functions and graphs. You are going to be able to graph absolute value functions, and we are going to talk about our essential understanding. Just as our absolute value of x is the distance from 0, the absolute value of f of x, or the absolute value of f of x, gives the distance from the line y equals 0. So our function of the absolute value gives us the distance to the line from y equals 0 for each value of f of x. We saw what the absolute value of f of x, the absolute value function looks like when we were talking about piecewise functions. And the simplest absolute value function is f of x is equal to the absolute value of x. That is our parent function. The graph of the absolute value of a linear function in 2 variables is a v-shape, and symmetric about a vertical line called the axis of symmetry. So we have a vertex and we have an axis of symmetry. Such a graph has either a single maximum point or a single minimum point called our vertex. So if we look at the graph, this is our vertex, and the axis of symmetry would be the line going through the middle of our vertex. Problem 1, graphing an absolute value function. What is the absolute value function? Y is equal to the absolute value of x minus 4. So we have to think about how is that different from our parent function. What is negative 4 on the outside of our function mean? That was d in our transformations, which means it goes down 4. So if we have our absolute value graph, I have 1, 1, 0, 0, negative 1, 1, 2, 4, negative 2, 4 as my absolute value graph. Now I would take that and move them down 4. So that my green graph shows the function down 4. Problem 2, combining translations. Which of the following is the graph of y is equal to absolute value of x plus 2 plus 3? We still need to be thinking about a, b, c, and d here. So think about our parent function, y is equal to the absolute value of x. So it's not just y is equal to f of x, now it's the absolute value of x, because we have an actual function. And what is different? The plus 2 on the inside and the plus 3 on the outside. The plus 2 on the inside was c, and if c was positive, we move to the left 2. The plus 3 is d. If d is positive, we move up 3. So that means our starting point, which was at 0, 0 for our parent function y is equal to the absolute value of x, is now going left 2 and up 3. So this is our vertex, negative 2, 3. We need to find the graph that has negative 2, 3 as our vertex. Not A, not B, not C, but D, negative 2, up 3. So the transformations of C and D are going to tell us our vertex or our starting point while we're graphing. It is the opposite of the inside and the outside. Please write down the steps for graphing. We have to find our vertex first. So once again, our vertex was the opposite of the inside, which is the opposite of C, the same as D, or opposite of H, K. Draw our axis of symmetry. That is the vertical line through the vertex. We can write the equation of our vertical line through the vertex as x is equal to the x coordinate, opposite of h. Table of values. We're going to focus on one side of our axis, and then we are going to reflect across our axis of symmetry. So, the right branch of the graph of y is equal to absolute value of x has a slope of 1. The graph of y is equal to a times the absolute value of x, where a is greater than 0, is a stretch or compression. We know that. If a is greater than 0, we have a stretch or compression. And that a is the slope. So we can graph using a as our slope because we have two lines that are connecting at our vertex. If we have y is equal to negative a times the absolute value of x, that's a reflection, and then we are going to have our slope be negative a. We're going to be going down instead of up. So, what is the graph of y is equal to 1/2 absolute value of x? First, our vertex. Since we do not have any shifts, our vertex is 0, 0. Make a point there. We have an axis of symmetry going through 0, 0. A is equal to 1/2. That means our slope is 1/2, which means we go up 1 over 2. We can take those points and reflect them onto the other side of our axis of symmetry. So 1, 2, 3, 4, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6, 7, 8. And now we connect our points. At the end of our V-shaped graph, we should have arrows because those two sides are going on forever. Writing an absolute value function. What is the equation of the absolute value? First, we have to find our vertex. So we look at our vertex here. It's to the left 1, up 1, 2, 3, 4. So negative 1, 4. Identify A. Since we are opening down, we know that it's negative. And let's look at our slope. Find 2 points. Down 1 over 1, 2, 3. So it's negative 1 over 3. Now can we write our equation? Think about our equation. Y is equal to A f of x. F of x plus or minus c plus or minus d. But instead of f of x, it's the absolute value of x. So negative 1/3 absolute value of x. We want minus 1, so plus 1, because opposite on the inside, plus 4 is equal to y. Now you guys try these. Find the vertex and the axis of symmetry of the graphs of each function.